All right, so this video is going to talk to you about how to use video analysis looking at projectiles motion. So I'm going to scroll this ball forward until it's completely out of the hands. Free fall motion is when an object is only under the influence of the force of gravity, so it cannot be touching any hand. Now, before I move forward with dots, I'm going to click on this button system on the left, and I'm going to drag this to my known distance. So if you see on the bottom of the screen, there is a ruler, and that ruler happens to be 1 meter. You created videos where you tossed a basketball or a volleyball, and you should have had some kind of measurement device in the back, and then you do that. All right, now I'm going to come to add dots. Now that I have my ball out of the hand, I put a dot in the center of the ball each time. So I'm going to do that. A little bit tedious, but once we have it, we'll have some great information. The higher you toss the ball, the more likely it is you're able to get lots of dots, as long as the motion stayed in the camera view the entire time. All right, that's good enough. I could continue, but that's good enough. Now, what you're going to see is, again, notice that the ball, on the entire path of the ball, I'll back this up, every dot, the ball was not in the hands, and on the other end, it did not. I stopped dotting before it touched the ground. All right, now when you look on this left side, you can click on this axis and you can toggle to see specific graphs, okay? So in the lab, it will first ask you to explore the x position and answer things about that. Y position, x velocity, y velocity. If you have this and you want to find slope, you just go here, this little curve. You go to apply curve fit, linear, and it will give you the linear fit for this linear line, y equals mx plus b, where m is the slope. Okay. Another graph you can choose, for example, would be the x velocity. Now notice it looks like the data is all over the place, but if I go here and I go to edit graph options, I'm going to take the y-axis from 0 to 5, and you see that it looks relatively flat. That tells me that my my x velocity graph should be flat. Now, if I want to see what is the average or mean value of that, I can go here and I can say view statistics, and it will say, hey, the average value is around 2.1 meters per second. Okay, so that can be useful. And that is, those are the main things that I wanted to show you in the video. Now look at how we can use vectors. And so if I go to add, and here I see vectors, I can specify that I want to see velocity vectors, okay, and see vectors in the x and the y, and I can choose a scale factor. I can make them relatively small or relatively big, and when you see that, you're going to notice something about the vertical vectors. So if I just focused on the vertical vectors, you see there all the way up, the relative length of a vector, I'm comparing this vector right here that's tall to this vector right here that's smaller. The relative length of a vector tells you relatively how fast the object is going. So this one indicates that it's going faster in the upward direction versus this one where it's going slower in the upward direction because the vector is smaller. The direction of a vector also tells you which direction, in this, if it's a velocity vector, which direction it's moving. So the fact that this is moving up and this is moving down tells you that the vertical velocity is upwards initially and downwards later. And that makes sense. If there's no vector, there's no velocity. Now, if we look at the horizontal vectors, you can also compare the length of those vectors all the way across.